Very good evening, everyone. This is Rajendran here, joining from Market Calls, and welcome everyone to Chapter 3 of Data Visualization. So this is a 4-part series, and we are talking about Python for traders, and we are learning the very basics about Python, and we are learning about how to implement the data analytics, data visualization, particularly related to stock markets. That is what we are learning in this session. Particularly in today's session, what we're going to learn is we're going to learn about a lot more interesting charting components, particularly like Matplotlib, Mplfinance, Seaborn, and Plotly. So these are the 4 important packages that we're going to learn about that. I hope my audio and video quality is good enough. Of course, I'm having some throat issues. So I'm in Bangalore and the climate is pretty chill here. And then last couple of days, I'm having some throat issues. Today, more or less, it's fine. I've been taking some medication, so my voice quality might be trembling a little bit. So bear with me, but otherwise we are good to go. I hope my audio and video quality is good enough to kickstart. If you, I can guarantee you one thing: today's session is going to be a little bit more exciting, interesting also. So try to make it as interactive as possible. Try to ask as many questions as possible so that you'll also learn many things, and I also try to give the maximum from my side. All right, so let's straight away start with the Visual Studio. So here is my VS Code over here. And we are going to look into a sort of a quick revision before getting into the Matplotlib tutorials. So first of all, I'm going to import all the libraries is what I'm going to import here. I'm going to import the Pandas library. I'm going to import Yfinance. I'm going to import as an alias as YF. Seaborn, I'm going to import. Seaborn is again more of a charting platform, charting library. It's a third-party library. Doesn't comes with directly with the Python installation. It will not come with that. We have to install using the pip command. So pip install Yfinance, pip install Seaborn, pip install Matplotlib. Ensure that you already installed in your machine. So once the libraries are installed in your machine, you're good to go with the importing. So I'm just importing all these libraries. I'm seeing a tick mark over here. You see that the tick mark, that means all the libraries are fine and we are good to go. That's what it means. Now what I'm going to do here is I'm going to import the last 5 days of intraday data. 1 minute data is what I'm going to fetch from Yahoo Finance. So I'm going to fetch it. So Yahoo Finance has a function called history. There are 2 ways you can download the Yahoo Finance data. Either using a history or you can use the download yf.download. You'll be able to get that. So here I'm using the history as a function. So if I execute that, I'll be getting a data in a data frame format. I'll be getting the open, high, low, close, volume, dividend, and the stock split. So for the last 5 days of 1 minute intraday data is what I'm getting over here. Of course, there is one problem with this. The problem with this, not a problem though, but somehow Yahoo Finance, right? It is not fetching the today's data. It is only getting the today's closing data only it is getting, because today is a Saturday, right? So, but markets has been there because exchange has been testing the disaster recovery zone. So for that, they kept the markets and Monday being holiday for Ayodhya reopening. So we are getting in a data frame format, but that's fine. We are getting an additional extra column over here. We are getting the very recent open, high, low, close is what I'm getting for the day. But otherwise, rest of the data seems to be fine to me, right? So generally, we don't get to see this kind of issue because of Saturday. Maybe Yahoo Finance may not be providing the data on Saturday. Probably they may not be aware about today's market activity. Probably they would have not coded in their system to provide the data, particularly if at all there is a market on a Saturday. Anyways, that's nothing to do with that. So I'm just printing the data frame here. I'm just putting the data frame inside df. So df is the variable. Inside that, I'm storing the pandas data frame. So let me store the data frame. So one thing to remember here, right, data frame is nothing but an individual series. So each and every column is nothing but what we call as a series. So one of the series, Pandas series, I'm going to open over here, df.close. So this is just to access a particular column. So I'm just accessing a particular column over here. We also have an index. You see that by default, when I am downloading the data, the date time is set as an index over here. This is very, very essential when you want to do any operations or when you want to perform any plotting or something like that. The index setting is very, very important. An index always, if it is in a stock market data, it should be in a YYYY, MM, and DD format, followed by that we are having an hour, minutes, and seconds. So that is what we are having it in railway timings. That is very, very important. Just like that, we cannot plot. If I am reading a data from a CSV file, definitely I have to set the index. Because when I'm reading from the, straight away I'm reading any data from a CSV file, right? I may not have the index configured properly. So I have to go and configure the index. Then only I should be able to do other manipulation stuff. All right, so we learned about the df.close, right? So which is nothing but a series. So it is nothing but it brings was what? It brings the Pandas series. Pandas series. Each and every column is called as a series. We already learned in the previous session itself. Now followed by that, we are having df.head. What does a df.head does? It prints the last five, the very top 5 records is what it gets us. So this is nothing but the head. And this is nothing but the tail. Tail brings us the very recent data. Right, so I'm just getting the head over here, which is nothing but the recent information, and tail nothing but the top information is what I'm getting over here. And once I got that information, I'm gonna print the data type. So let me get the data type over here. So the data type is the function which will get us what kind of data type it is. Of course, it is a Pandas data frame. That's what I'm getting here. I can also filter the values. I can say like, get me the values only if Nifty value close is greater than 21,600. Only those records you get me. So it is getting those results. So I'm just doing some sort of filtering. We can do filtering. I can also extract the columns as well. Let's say I'm just trying to extract the columns. So there are a list of columns: open, high, low, close, volume, dividends, stock splits. So these are the columns I'm getting over here, right? I can also reset the index. If I reset the index, what happens is like the date and time becomes a column. Earlier date and time is not a column. Earlier date and time was a index, but now I have a auto numbered index is what I'm having over here. Starting from 0 till the total number of records minus 1 is what I'm having here. If the total number of records is 1,874 rows and 8 columns, so 1,874 minus 1, which is nothing but 1873 is what I'm having here. Now what I'm gonna do here is once I'm done with that, I'm gonna plot a line plot. So I'm just gonna download the Tata Steel data. So here you can see that I'm downloading the YF. I'm using YF.download to download the data from start date to end date is what I'm using. So previously I had used a ticker.history. You see that ticker.history was I had used. It's a different way to download the Yahoo Finance data. Now I am going to use a different methodology. I'm going to use what? I'm going to use yf.download. I'm just passing on the ticker name. I'm sending the start value. I'm sending the end value over here, right? See, one thing if you understand, when I'm passing the function value, here I'm passing, I'm not mentioning any ticker name over here, but here I'm mentioning start and end. Do you think why I'm have to send these values over here? Any idea? Just think for a moment why we have to do this. So some places I am passing the parameters just like that I'm passing. And some other places I'm mentioning the variable and then I'm passing the value over here. So I'll tell you why is it so. Let's say I'll call the function yf.download. If I open it, it automatically show me the intelligence. It's saying like my first value is a ticker value. So if a first value is a ticker value, I can directly go with that. So I can directly mention like, sometimes like I'll say like reliance.ns, comma. The second one is what? Second one is showing like start value. And then a third one is a end value. Now, sometimes I want to access the threads straight away. I want to access the threads. So what I'll do is like, I'll say threads equal to, and then I'll give the value of the threads, right? So I'll be giving the value of the thread straight away. I'll be able to give the value here. So these are optional values. So if I don't want to specify in an order, I can directly mention the thing. So here I'll say like start equal to, I'll say like 2024 and 01-01 and comma end equal to. So if I don't want to call in order, of course, here I'm calling in order, but if I don't want to call in order, I can pass any parameter by just specifying the variable name and I'll be able to transmit those values. All right. So why I had used here is so that you understand that this is the start value, this is the end value. If I don't use it, I can directly pass like this also because it is still in order. It is still in order, but for the end user, tomorrow if I open the code, I will get confused myself. What is this and what is this? Which is the start value? Which is the end value? How should I know that? What values are getting passed? Now, if I have the values over here, at least I'll get to know that, yes, this is the start value, this is the end value. So data will be fetched only between these two dates is what will get fetched. And then I'm going to use the SNS. SNS is nothing but what? Is nothing but a Seaborn plot, like Seaborn alias. So I'm using the Seaborn alias dot line plot, and I'm passing the x-axis as the date and y-axis as the close, and I am passing the data frame. Simply straight away I'm plotting the data frame, and then I'm using plt.show. Anyways, I'll come to that part later on because we're gonna study Matplotlib and Seaborn in a very detailed fashion. So at this point in time, I'm just simply plotting a line plot, right? So I'll try to explain later on what are these things and how to implement those things. Later on, I'll try to explain here. So basically, it tries to download the Tata Steel data and it is trying to plot the charts over here. It's a simple line chart is what I'm getting over here. And if in case, if I want to, let's say my data frame, let me go and pull up the data frame over here. You go and pull up the data frame. I'm just printing the data frame in a table format. If I want to access the very recent closing value, so this is my very recent closing value. If I want to access that, I can access with an iLock. iLock of -1. So iLock of -1 represents what? So it represents in terms of, let's say something like, so this is 0th record. This is first record. I can keep on going like this. This will be the nth record. Or I can also do like this. This is -1 record and this is -2 record, right? So we can also do it in a reverse mode also. So if I want to fetch the recent data of close, I have to say dot iLock. I'll mention the column, df.column. That means I want this column here. Now in this specific column, I want to fetch the very recent data. That means iLock -1. So iLock -1 means it fetches the very latest record is what it fetches. And then I'm adjusting to 2 decimals over here. Notice that .2f. So here, if you remember, we are using a colon over here. That means we are doing a formatting. If you remember from the string formatting, right? You have string formatting. The colon represents what? We are doing a formatting. And we are adjusting to 2 decimals. That means I want only 139.60 only. Even though my record is having a lot more numbers here, I'm not bothered about that. I'm only bothered about having a 2 decimals only here. So after printing that value, what should I get? I should be getting the very recent value is what I should be getting over here. So this way I'll be able to get the current value of the Tata Steel. I mean, the current closing value of the Tata Steel. Current closing value of Tata Steel is, I'm just printing with the adjusted 2 decimals is what I'm printing over here. Followed by that, I may want one day before data. So I want to say like previous day closing value of Tata Steel is, I say iLock -2. If I say iLock -2, automatically I'll be able to get the yesterday's closing value, right? So yesterday closing value is what I'll be able to get. And not only that, what I can also do here is I'm going to have a data frame. Let's say I'm having a closing value, right? So I'm also going to have one more column. Let's say I'll say like df equal to or df of previous close. I'll say like previous close equal to, I'm going to do something called shift. I mean, df dot shift of df dot df of close dot shift of 1. Now, if I'm going to do that, what happens is like all the data will be shifted towards the right. And now if I could see here, let's say I'll list the data frame. I'll have a new column added over here. You can see that I'm getting a new column added over here. So what is happening here, I'll tell you. So the shift column will be shifting one bar towards the right. Let's say I'm having, imagine I'm having some 5 candles in my data frame. So this is my 0th candle. This is my first candle, second, third, fourth, and fifth. Okay. So let's say I'm having a value like 100, then 101, 105, 107, 108, and my current closing value is like, let's say 106. So these are the values I'm having in my data frame. I'm having only 6 candles. Imagine that is the close. So that is a close. A shift of one, what is it does is like a shift of, the closing value I'm shifting by only 1 bar. What happens is like the first value will become empty. Everything will be shifting 1 bar towards that. So first value I'll be getting NAN. This 100 will be coming over here. This 101 will be coming to the next block. 105 will go to 105 in the third row, and third column, and the fourth one I'll be getting 107 and 108. So every value will be shifted by 1 bar towards the right is what it shifted. So here, this is my current value, means my shifted value, the recent value I'll be getting, the very recent value will be my yesterday's value. So why this will be useful? If you ask me, it will be very useful in building trading strategies. For example, if I want to compare today's value with yesterday's close, I want to compare with the yesterday's close. In that case, probably I have to write something like this. Let's say, like, I just want to say whether it's a positive candle or a negative candle. I'm going to put a new column. I'm going to say like, let's say like signal. So my signal is going to be like, if my DF of close, if that is my current close, if it is greater than my yesterday's close. How do I know yesterday's close? I can easily compare. I can say like DF of, I can use previous close, or I can say like DF of close or dot shift of 1. Now this way I'll be able to compare current close with my previous close. So this is my current close and this is my previous close. I'm checking wherever the current close is greater than the yesterday's close, it is going to print a true value. Otherwise, it's going to print a false value. It's going to compare each and every row in the data frame. It's going to compare and it's going to give me the new value in the data frame, new column in the data frame called signal. Signal is the column name. The signal in the column name is going to be either true or it's going to be false. So let me print the data frame here. The new data frame goes like this. You can see here. Now, of course, this is a very simple example though. I'm sorry. So this is a very simple example though, but this is a very basic foundation for writing your trading logic. So here, what is happening over here? Here actually, when I am checking over here, the current close, I'm comparing with the previous close. So where is the current close here? Let's say current close. This is current close. I'm comparing with my previous data close. So current close, I'm comparing with my previous data close. Wherever you can see that the current close is greater than the previous day close, it is printing true value over here. When the current close is less than the previous day close, I'm getting a false value over here, right? So likewise, it keeps on printing each and every row is compared. I'm getting a series of true and false is what I'm getting over here. Panda series of true and false. Later on, you can feed to your backtesting engine and you can backtest your rules. Right? So basically, when you want to frame a signal, the end output is going to be either true or false. You have to write a condition. So we are writing a very simple condition over here. I'm checking if the condition today's close is greater than yesterday's close. Print me true, otherwise it print me false. That is what I'm explaining over here. Right? All right, cool. Let's move a little forward here. Now, again, what I'm going to do here, I'm having the index. The index has been set by default as year, month, date. I'm going to reset the index again. So if I reset the index again, it becomes a column. The date becomes a column, and I have an automated numbered index is what I have. Now, what I am going to do here is I'm going to remove the 4th and 5th column is what I'm going to remove over here. Let's say if I remove the 4th and 5th column, you see that what is getting removed over here? So what is getting removed over here, I'll tell you. So what is getting, so this is my 0th column, 1, 2, 3, 4, and 5 and 6. 5 and 6 points to adjacent close and volume, right? So always the numbering here is done from zeroth column to the, so this is zeroth column, not the index. You just don't consider the index as a column. Index is not a column. So the date is a column, that is zeroth column, 1, 2, 3, 4. So what I want to remove is the fifth column and sixth column is what I want to remove. If I remove it out, my data frame looks something like this. Let's say I'm going to plot the, let me plot the data frame again now. So my new data frame. So I'll do one something. I'll try to check the data frame here. Now the new data frame contains the value without the adjacent close and adjusted close and volume row. That is totally missing here because I dropped the columns. So df.drop is a function. Df is nothing but a data frame. Any data frame, if you want to drop a certain column, you have to tell which column that you want to drop. I'm passing on like a list is what I'm passing. 5 and 6, I'm passing like a list. And I'm setting axis equal to 1 and in place equal to true. So these are the values that I'm setting here to drop the particular columns, right? And then I'm printing df.columns. Of course. So if you have any questions, please type it out. I'll just wait for a minute or so. So Nayan Agarwal is asking about ticker.history function, why we are using the exponential mark over there. So that is nothing but the Yahoo Finance symbol, right? Maybe I'll show you the Yahoo Finance symbol over here. Go to my browser and from here I'll say like Yahoo Finance, yahoo.finance. So here, let's say the ticker symbol, you see that the ticker symbols with the index are mostly having that exponential mark. This is like GSPC, that is S&P 500 index. So all the index will be having a exponential mark in Yahoo Finance. Something like Nifty, let's say I'm just typing Nifty over here. You'll be getting an NSEI with the exclamatory mark. And then this is with NSE Bank over here, right? So that is how you can understand that it is more of an Yahoo Finance symbol. So there is another question from, what is the question over here? Another question is from, a very interesting question though. Neera is asking, what do you mean by in place equal to true? See, in place is a parameter. It is very often used in functions and methods within the Python libraries, right? So particularly in something like a pandas. So it indicates whether to modify the original data structure or not. So for in this case, we're having a data frame or series, right? So directly, we are trying to create a new one and returning it. If I'm saying like in place equal to true, it creates a new data frame instead of maintaining the original structure of the data, right? So it in place equal to true, if I'm giving means it will change the original object and it will not return anything. That's what it means. When I say in place equal to false, that means the original object will not remain unaltered. My original data frame will not be changed at all. So that's why we use in place equal to true, right? I mean, I'm using in place equal to true because I want to remodify my data frame. So I'm just, you can see that I'm just remodifying my data frame over here. So my new columns will be impacted by the decision what I'm making over here. I'm just trying to remove the column 5 and 6. And it also updates the new data frame if I give in place equal to true. All right. So Ramachandran is asking like stock name.ns, can we download for BSE and commodities, etc. See, when it comes to Yahoo Finance, I think Yahoo Finance supports NSE and BSE data. Maybe something like, let's say I'll try to go with Yahoo Finance. Let's say I'll type Reliance. Let's see what happens. Reliance. Probably will be able to fetch the Reliance NSE data as well as the BSE data. So BSE it starts with reliance.bo. Can I download commodity data or futures data or options data? If you ask me, absolutely not. You cannot do that using Yahoo Finance. You can do that using the third-party library from TradingView data feed. Maybe if time permits, in tomorrow's session, I'll show you that how you can download futures data or commodities data from the trading view data feed. There's a TV data feed library is there. So tomorrow I'll show you on that. And if in case if you want to download the options data, then no other free resources are there. I mean, you can download, but you can download from the brokers. If you are having a reasonable brokers who are providing APIs, you can download the data of options, commodities, currencies, anything that you can download from your broker. That is totally possible. All right. So let me take two more questions. Sabajit is asking, can you please explain in place again? I missed it. See, in place, as I said, in place is nothing but what? It's a parameter we often use in functions and methods, particularly in Python libraries. So here we are using in place equal to true, which is very much used in Pandas data frame also. It's a common theme. So what I'm saying is like you change the structure. I'm deleting 5 and 6, right? So I'm deleting 5 and 6 from my data frame. You also update the new data frame is what I'm giving an instruction over here. So this is my new data frame. It's having the data, but you can see that the columns 5 and 6 is missing. So here I'm using in place to mention that you just alter the original data. That's what the instruction I'm giving here. All right. Manish is asking, let's say plot highest OI on call side and option chain. So maybe if time permits, I'll talk about that, about the option chain. In fact, I also written an article about that as well. So later on, we'll come to that part. All right, so let's move a little forward because a lot more things we have to cover. So the next one I'm going to open up is like the Pandas data manipulation. It's a very interesting one. So here, what I'm going to do here is I'm having a local CSV file over here. You can see that there's a CSV file. Basically, I open a folder called Python for Traders Part 3. So I just choose an open folder and then I create a new folder. And then I just selected that particular folder is what I done here. So inside the folder, I'm having a CSV file. Maybe I'll show you the CSV file. What is the content of the CSV file? This is the content of the CSV file. Here I'm having the content of CSV file with the ticker, date, open, high, low, close, volume, previous close, and some linear regression values, Hull moving average volume, and some turbo RSI and ATR. So various indicators is what basically I'm having in this particular code. Right, lot more detailed data set is what I'm having over here. So this thing, this particular this particular CSV file is what I'm going to open using Pandas data frame. Okay, so let's see that. So I'm just using a read underscore CSV function to open the CSV file, which contains the Excel sheet, CSV style data. It is a CSV file only. So I'm just downloading the data. I'm just putting in a data frame. Let's see what happens here. So what happens over here is you see the first thing that you always have to visualize is like what is the index I'm having over here. Of course, index is auto numbered here, right? So because it is not automatically setting the index, we have, as a user, we have to go and set the index here. So once I download the data, it fetches me the entire data and puts in a data frame. That's what the pd.csv file does. You know, pd is nothing but the alias, which I used over here. And we are getting in the data frame df. So now I'll be able to retrieve the single series. I'm retrieving the series of df of close. Now what I'm going to do here is I'm just going to do a date formatting is what I'm going to do over here. See that the date formatting I'm doing here using the I'm using a function called pd.toDateTime. So this will convert my data in a date time format, right? So I'm just saying which column to convert. I'm also giving a format over here, %d, %m, %y. So my column will be looking something like this. So you can see that the daytime column, it just get formatted. So what happened over here, like it get converted into date and time format. Earlier it was only a text content. Now from a text content, it becomes a date time content. Now why this is more important? Because then only I can set the index. So you can see that I'm just setting the index over here as the date column and in place equal to true. You know, in place equal to true means what? I'm just modifying the data frame itself. If I don't set, let's see what happens first. If I say false, what happens first here? You see that my data frame is not changing at all. The date still remains as a column, right? But if I give true, what happens is like the data structure changes. Now date will become the what? Date will become the index. Now we can see that the date becomes the index over here. That is the importance of in place equal to true, right? It is not only particularly for pandas. You might be using in various libraries, various Python libraries you may have to use whenever you want to change the structure. You're doing some operation. So here what operation we are doing? We are trying to change the index. So, and then I'm saying in place equal to true. That will totally change the structure of the data frame. All right. So now we got the date. Now this is very much important. Now what I'm going to do here is so this is a daily data. So what I'm doing here is I'm resampling to the monthly data is what I'm doing over here. And just I'm calculating the monthly mean returns is what I'm calculating over here. So now df.resample of m, this will convert my daily data into a monthly data, right? Monthly data, and I'll be getting a mean. So you can see that one more extra column gets added up. It's a very lengthy column though. So resampling, what is doing is like entire data. So whatever the data I'm having here, it is totally converting into a monthly data frame. So you can see the records over here. This is my daily data is having 6750 records, whereas the one which I convert into monthly, it is more or less having a very less records. So if I print the shape, I'll get to see the total number of records over here. So this is df.shape is my actual data. But if I go to df underscore monthly, right, you can see the shape of df underscore monthly. So my daily data shape is 6,950 records. This is shape of daily data. Whereas I'm going to show you for monthly data as well. Shape of monthly data. Dot shape. We can simply use a dot shape and then we'll be able to extract the monthly shapes over here. You can see that hardly 327 months is what of data I'm having. It's a complete historical data. So I'll be able to get the monthly data shapes as well. So what it does is like it converts this resample does what? It using the daily data frame, it converts into monthly data frame. So particularly if you want to do multi-time frame analysis, the resample will be useful. So let's say you are in a 15-minute chart and you want to refer the hourly time frame. In that case, you have to do the resampling. One thing you have to remember, you can always convert a lower time frame data to higher time frame data. You cannot do the reverse way, right? So 1 minute data, if you're having, you can convert into 5 minute or 10 minute, you can do that. Daily data, I cannot convert to hourly data. That is not possible. From higher time frame to lower time frame, you cannot do that. But from lower time frame, you can always convert to a higher time frame. So that is what the importance of the resampling is. Particularly, this resample is very, very helpful if in case if you want to do or if you want to perform in the multi-time frame studies. So followed by that, we know what this does. It extracts all the columns. That is what it does here. Now, what I'm going to do here is I'm computing the EMA 10 and EMA 5 is what I'm computing over here. And then I'm updating the data frame. Right. So along with the existing thing, I'm also computing EMA 5 and EMA 10 is what I'm computing over here. So I'm using a function called EWM. So EWM, I'm saying like a span is like 5. A span is nothing but the length of the EMA. And I'm saying like adjust equal to false dot mean. Now this everything put together, I'll be getting a exponential moving average is what I'll be getting over here, right? So EMA 5 and EMA 10 is what I'm just calculating. I'm putting into a variable 5 and 10. So this will give me a series, Pandas series. That Pandas series is what I'm storing to the new column, EMA 5 and EMA 10. And then I'm printing only the head. That is nothing but the very top 10 data is what I'm right from the start. First 10 values is what I'm trying to print over here. And if in case this is my new data frame, right? This is my new data frame. What I'm trying to do here is like I'm also trying to convert. I'm just trying to store this into a CSV file. So I'm just putting a new CSV file name. I'm also saying like index. When you are writing to a CSV file, you write the index also. I have to specifically say that. Otherwise, the date column will get missed. If I say false, let's say if I say false, now what happens is like it will write the entire data frame, but it will miss the index column. So let's say I'll write it. So you see that the CSV file has been created, a new CSV file. It creates in the same path itself. So which folder I had, in the same path only it gets created. If you see here, everything is there. The date and time column is missing over here. So now what I have to do is if I want to include the date column also, I have to say that index equal to true as well. So true. If I give this, now what happens over here? You will be able to see if I go and open the CSV file, you can see that now date column is also here. Very interesting, right? So that is how the 2CSV does that. So basically there are two important functions that you need to know. The very first function is read underscore CSV, that will read from a CSV file, right? It can be from a file or it can be an internet link also. Later on, I'll show you the internet link, how from the internet you can download a CSV file using the same read underscore CSV. And then we are having what? We are having 2.csv. This will write to the CSV file. Write the Pandas data frame completely into a CSV file. Hardly one line of code. It does the rest of the value. Not much of a complex thing. That is why Pandas is so popular, right? So that is why Pandas is so interesting also. It's very easy to understand, very easy to read. All right. So now we had complete the quick overview of the Pandas function. We had explored some of the very basic Pandas functions over here. Now this Pandas function is going to be a lot more helpful when you are playing with data visualization, when you're doing data manipulation, data cleaning, data visualization. So these functions are a lot more helpful. Anyways, we'll also look into some of the other very interesting Pandas data frame, Pandas functions also. A lot more other interesting Pandas functions is also there. We'll see one by one. Right. So now what we're going to do here is we're going to look into a very interesting stuff here called a very interesting library is what we're going to pull up over here. So what are the libraries that we're going to discuss? I'm going to show, first of all, before I'll tell you how you can install in your library, you just go to your terminal. So from the terminal, you just install all those libraries. In my case, all the libraries has been already installed. So in your case, if you haven't installed those libraries, you just type pip install matplotlib. So matplotlib is a charting library, particularly for data visualization. Back then Python, right? There is a tool called MATLAB is very popular. MATLAB is a very popular tool for implementing data science. It is also used in trading industry also, financial market industry. MATLAB is also used. Inspired from that only, they had built a data visualization package called Matplotlib, which is inspired from MATLAB. And then I'm going to install, let's say maybe Mplfinance, if you don't have, you install Mplfinance. And probably you also have to import the Seaborn and Plotly and Mplfinance. So once you install all the libraries, in my case, as I said, all the libraries has been installed. So once you install all these libraries, you're good to go, right? So in my case, as I said, all these libraries has been already in place. So nothing much to worry about that. I can close the terminal itself here. Anyways, let it complete so that I'll close the tab. Parallelly, what I'm going to open here is I'm going to open a very simple tutorial here called a Matplotlib example is what I'm going to download. In Yahoo Finance, right, you can download not only Indian markets, probably most of the global instruments also you can download. So for example, NVDA, if I want to explore the chart of NVDA, I'll say the start value and end value. Probably end value, I'll try to give it the very recent data is what I'm going to give here, up to 2 days up-to-date data. So that will fetch me the NVIDIA data frame. So Pandas data frame. So first time when I'm running, right, it will be asking me to select the kernel. So I'm just selecting the kernel as Python 3.11. That is my recent version which I'm using. So it will take a little bit of time. First time the kernel will take a little bit of time to set, right? It will not run like a regular Python program. So only the first cell execution will take time. The other cell will be executing a bit faster. And of course, the data started downloading. So data download time is also involved over here. You can see that almost 7.6 seconds is what it is taking to download the data. So once we are done with that, we are having a data frame, right? And You can also see here, right? So what I'm trying to do here is like the data is the data frame. I'm just setting the series. You can also see here I'm using the Matplotlib. I'm not using the Matplotlib. I'm using something called PyPlot. Now, what does this dot PyPlot means? Can anybody know that what is a dot PyPlot means? I'll tell you what exactly. So Matplotlib is a main module. Inside that, there is a sub module is there, maybe a subfolder or something like that. Imagine Matplotlib as a main folder. If I am having a main folder name, let's say, so this is my main folder name. That is my matplotlib.py. Oops, just give me a sec to put my charger. So this is matplotlib library. Why? That's going to be my main library. Inside that, I'm having another subfolder. It's a folder here. So inside that folder, I'm having let's say the folder name is pyplot. So inside that, I'm having an pyplot.py. So I'm just basically referring in submodule here. It is basically a submodule. I might be having multiple modules. One among them is a submodule is a pyplot. It supports a lot of Matplotlib supports a lot of module. One among them is a pyplot, right? So we talked about implementing a line chart, right? So here I'm just implementing the series, right? So the data series, I'm saying like plot, I'm giving the title, I'm giving a PLT. So PLT is the alias for Matplotlib. Matplotlib dot pyplot. That is what the submodule I'm using over here as PLT, right? As PLT. So using that PLT, I'm setting the X label, I'm setting the Y label, and then I'm showing the values over here. If I try to execute this, so basically you can see that. So what we had at the top is the title. Here is what we're having a title over here. This is the title section, title. And we are having the X-axis and Y values title over here. So this is the X-axis title, and here we have a Y-axis title over here. We can also have something like called as a legend. Legend, if I am gonna include, maybe that will be even more, a little bit more interesting. I would say that maybe I'll show you the legend. So if in case, I can also add a couple of things more to this. So let's say what I'm gonna add here is, I'm gonna add a grid. So plt.grid. So if I'm gonna add a grid, it looks like a graph chart probably. You can see that you'll be getting a vertical X and Y grids I'll be able to enable. And not only that, I can also say like legend I can add. So legend is something like, it is very, very interesting one. So legend, I'm going to say like, I'm just going to put a location. I just want to plot the legend maybe over here, kind of an upper left is what I want to plot. I'll say like upper left is what I want to say here. So the legend will show you what kind of data that I'm trying to display. So I'm trying to display the closing price. You can see that. So particularly when you're doing a multi-plot, it will be very helpful, right? So I'm also saying like where I want to plot. So the location here is like upper left. I can say like upper center, upper right, or lower left, lower center, lower right. I can specify that automatically. Accordingly, the legend will be plotting the legend over here. So if in case we don't want a legend, you can remove it, not option. Those are optional one. Right. So what is the bare minimum one which is required here is like you don't need a grid, you don't need a legend, you don't even need an X label, Y label. Without that also, you might plot the chart, but it may not be looking interesting. Right. So you just try to plot the chart. You just say which series that you want to plot, give a title. Even title is optional here. You just simply plot it and then show the plot. That's it. But if you want to make it interesting, you have to add the X label, Y label, legend, and grids. That will try to make your code, it will make your data better. And once you're done with that, we have a very interesting package called Mplfinance. So Mplfinance, right, we'll be able to plot candlestick charts. We'll be able to plot Renko charts. We'll be able to plot point and figure charts, bar chart. So all kinds of different varieties of candlestick techniques are possible using the Mplfinance package. So here I'm just importing the Mplfinance as MPF. MPF is my alias name. So I'm going to use mpf.plot. I'm saying like I want to send the data and type equal to candle and title equal to NVIDIA candlesticks. I'm also saying like bring the moving average 10 and 20 along with that. So it's a very simplified package. Straight away, it does what it plots the candlestick data along with my 10 and 20 simple moving average. I'll be able to get that, right? Probably better than Matplotlib when it comes to candlestick charts. Matplotlib, right? They don't have the default candlestick charts mode. You cannot plot candlestick charts using Matplotlib. But Matplotlib is a widely used package in machine learning and data science. Not in stock markets though. But still, if you want to do machine learning in stock markets, definitely Matplotlib is one thing that you cannot ignore. That's a very basic package. Even the another package, the Seaborn itself, an extended package of Matplotlib, right? Let's say if I want to plot a bar chart in a histogram mode, then I have to use bar. So bar means it will try to plot in a histogram mode. That's what it does here. You see that it is plotting the NVIDIA volume in a histogram format. And I'm also want to plot an simple moving average of 20. So you can see that I'm using a rolling function over here. So rolling function is part of Pandas. I'm saying windows equal to 20 dot mean. That will be helping me in calculating the 20 period simple moving average. I'm calculating that. You can see that I'm just calculating, and this I'm gonna display the data frame here. So the data frame looks something like this. You see that I'm also getting a non-value. Null value is what I'm getting over here. I want to remove those columns with null value. So in that case, what I'm saying is like, I'm saying like this data dot drop NA. So if I do that, what happens? It will remove the columns. I mean, it will remove the rows, whichever the rows which is having NA values that will get removed. You can see that now my new data frame is having what? The NA values is totally got removed. But if you look into the actual data frame, let's say I'll go and look into the actual data frame over here. Let's say I'll go to data. What do I see here? I still see the non. Can anybody say why I'm still seeing the non value? I just try to remove the data.drop NA. It got removed over here. But when I type the data frame, I'm still getting the non value. Why is it so? Anybody? Yes, exactly. In place equal to true. I have to give in place equal to true. Maybe if I give in place equal to, what I'm saying is like you remove the NA. I mean, you remove the NA values, but don't change the structure of the data frame. That's what I'm saying over here. If I say in place equal to true, that means I'm allowing to modify the data frame. So when you're using this, use it very carefully, because when you do this, you cannot be retrieve the thing back. Okay, when I say true, right, it should be in capital true, because Python is case sensitive, right? So if I do this, see that the data frame structure got changed, and now my data will contain values without NaN values, right? So I hope now you understand the true meaning behind the in place equal to true. All right, so now I'm also plotting two things over here. I want to plot the close along with the SMA. So what I'm doing is like I'm sending these columns in a list is what I'm sending inside the data frame. I'm sending to plot. I'm plotting the X label as date, price, show. So this will be doing a multi-plot for me. You see that it's plotting multiple values in the same chart. And let's say you want to plot the returns in a bar plot. If I want to do, I'm taking the data frame of close. I'm taking a percentage change. So what this percentage change will get me is like, it will get me the percentage returns. So it will do something like this. It will take today's close minus yesterday's close divided by yesterday's close. So that's what it gives us. So I have to multiply by 100 so that I'll get in percentage terms. So I just multiplying in 100. What I am trying to do is like I'm trying to plot the returns in a percentage bar plot mode is what I'm. Bar plot means it is going to be a histogram plot. when it comes to Matplotlib. So I'll be getting the percentage mode. So I'll be able to see when NVIDIA, I think one of the day it had even done 8% returns from an intraday perspective on a closing basis. You can see that some places it had made 8% returns here. And even some places that it has been done like more than 4% crash multiple times. It had crashed minus more than 4% is what I'm able to see the crashes over here. Followed by that, this is an histogram plot. So this histogram plot does something like an frequency distribution, right? So it's more of a distribution plot. We say like that. We are collecting in 50 bins is what we are collecting. I'll tell you what exactly this does. So I'm having an daily returns. I'm taking the daily returns, putting in a data frame format. Maybe show you the first. I'll show you the data frame. So in this data frame, we are having a daily return also added along with that in percentage mode. So this is like 2.99%, and here it is like 5.6% return on that specific day. This particular day it is. Now, once I'm done with that, what I'm trying to say is like I'm trying to put in a histogram in a bin format. I'm basically collecting 50 bins. 50 bins, I'm just trying to check. For example, if I want to explain this before plotting, I'll say like, let's say I'm having a data. So one data is like 0, and then I'll say like 5, and then I'm having like 7, and then like 12, and maybe I'm also having negative values also. Let's say -5, then -6, and then -8, and then -9. So this is my data set. So I just want to put it in a bar plot. So if I count, I'm gonna count like this. If something like around 0 to 5. So 0 to 5, how many numbers I'm having? This is like 1 and 2. These are the two values I'm having, right? So 1 and 2. So it will try to plot me a histogram plot with a value 2 in my y-axis. And then, so this is from 0 to 5. 0 to 5. So maybe next bin, I'm going to collect from 5 to 10. So anything from 5 to 10, I'm going to calculate. So I'm having only one value here. 7 is the only value is coming in. So I'll be having in frequency of only one time it repeated between 5 to 10. And again, 10 to 15. So that is going to be my third bin, 10 to 15. So I'm having only one value again. This is by 12. So it will be plotting around 10 to 15, like 1. And -5, -6, -8. So again, -9. So these are, it comes around, let's say, -1 to -5, if -1 to -6 on the negative side, let's say. Or maybe 0 to -5. Hardly one value is what I'm having over here. -5 to 0. I'm having only one value here. And then finally, I'm having from -6 to -10. Right? I'm having three values. I'm having a -6, -8, -9. So I'll be getting a 3 values, -3. So this is how the histogram plot looks like. Now here how many number of bins? So I'm having, this is like first bin, second bin, third bin, fourth bin, and fifth bin. So here what I'm instructing is like you use 50 bins. You collect all the returns in the 50 bins and show me the plot, how the returns are falling, where the most of the returns I'm getting over here. So it will be help for you to visualize the returns. So let's say I'm just printing those returns. I'm just again using the plt.title, x label, y label, and then I'm showing that nothing much. So the only thing I'm using here is the histogram plot is what I'm using over here. If I try to do this, I'll be getting a NVIDIA return distribution plot. Now, what I can understand from here, very simple, right? So I can say like, I think only one time it is returned more than 8%, or maybe one time it returned more than 6%, or 7% more than one time. More than or more than 6%, if you ask me, I'm getting 3 values over here, right? So one above 6, one above 7, and one above 8. Likewise, I'm also getting between -4 and -6. How many times I'm getting? So this is 1, and this is probably 3. This is 1, and probably this is 1 again. So more than 4%, I'll be able to see like 5 times it crashed more than 4%. That's what I'm seeing over here, which I can also able to count from here as well, but this will be giving me the distribution plot. So I can also count from here as well, right? So this is one time, second time, third time, fourth time, and fifth time it crashed more than 4%. I can easily able to see from here. All right. All right, let's move a little forward here. That is all about the distribution plot is all about. Now let's say look into this one. So this is nothing interesting. I'm trying to download the Microsoft chart. So probably I'll try to download the very up-to-date data. So how long I'll be able to download the data? As long as Yahoo Finance provides. Mostly they're providing data from 2000 at least, I think. So 2000 or 2005 is what they're providing the starting point of the data. So you might have a reasonable amount of historical data from Yahoo Finance. I think mostly it is adjusted to split and bonus. You don't need to worry about that. So here, already I had downloaded NVDA data. And Microsoft also I'm going to show. So it's going to be a dual plot here. So two plots I'm going to show in one single chart. This is NVIDIA. Oops, what I missed here is like 20. Did I download the data from 20 here as well? Yeah. So I'll go back to the bottom and I'll say I'll execute the code. So now I'll be having a two plot. NVIDIA also I'm having, MSFT also I'm having over here. You see that it is plotting both NVIDIA and MSFT. MSFT means Microsoft. I'm trying to plot over here. So basically what I'm having here is like, I can also create a subplot. So yeah, sometimes I want to create two plots. So NVDA plot price on the top and NVDA volume at the bottom is what I want to plot over here. See here. So this is how it is. So I'm just having an NVDA and then I'm plotting an volume plot. Maybe I want to plot in a bar format is what I would like to plot over here. And in that case, what we can say, like in that case, we can say like bar plot is what we can specify. Plot plt.bar is what we can specify there. Let's see if we can make an arrangement of ax2.bar. I'll explain this because it requires a little bit of explanation here. See that I'm getting an closing price in a line chart format. In NVIDIA, I'm getting a bar plot is what I'm trying to do here. So first of all, what I'm trying to do here is in a single plot, right? This is a single, I'm having only one x-axis and one y-axis, one single plane. Inside the single plane, I'm plotting the NVIDIA also, I'm plotting the Microsoft also. I'm setting the title, label, and legend, and then I'm showing the values over here. Of course, legend is nothing but what? The value of legend is getting displayed over here. You can see that NVIDIA and Microsoft, it's getting displayed over here. That's a legend. And now what I'm trying to do here is I'm trying to include something called a subplot. You see that the plt.subplots is what I'm using over here. So another subplot, what I am trying to say here is I'm trying to say two things over here. One is I'm saying like 2, 1. So 2, 1 is in a matrix format. So means this is my first block and this is my second block. So that's what this is going to be my column. Column is going to be 1 and row is going to be 2. So this is my first row and this is going to be my second row. So you try to draw, first one is going to be a line chart and second one is going to be a bar chart. So that is how I'm just mentioning the subplots over here. How many subplots that you want to do, you just mention that. In my case, I want to have only 2 rows is what I need. So this is one here is nothing but in that 2, 1, right? This is nothing but rows and columns. Row and column. So 2 is nothing but the row, 1 and 2. And this one here, nothing but the column. This is column and this is the row. Right? That is how the subplots are getting created. And I'm also setting the figure size, the image size. So 10,6, that means that 10,6 means 10 is the height, width in inches, and 6 again is the height again in inches. So if you give a bigger number, you will get a bigger plot. Maybe I'll show you that also. Let's say I'm just giving 20,12. So right now you see the image size. So this is how the image looks like. Maybe the image is not comfortable to me. I want a bigger image. So what I'll do is like I just simply change the figure size to, I'm just doubling it, 20 and 12. So in that case, 20-inch and 12-inch chart is what I'm going to get, 20 into 12-inch chart. So that way I'll be able to get a very big chart over here, right? So you can see as clear as possible. You can go for any size. There is no limitation to that. So practically, you can go and give some practical numbers is what you can give. So basically 10 or 20 in that range, if it is there, it's good enough. So 10 and 6, I'll reset it back over here. And then I'm having an AX1 and AX2, right? So that is the AX1 and AX2 is what kind of an tuples I'm collecting in the AX1 and AX2. And another value I'm setting in the figure. So the figure will be having the final size and everything I will be having over there. So we have two different plots over here. So if I want to access, I have to say AX1.plot. Earlier we used to do what? We just simply say PLT.plot we used to use. When I'm using a subplot, I have to use AX1 and AX2. For AX1, I'm plotting it separately. I'm setting the title, I'm setting the Y label, I'm setting the legend. So everything I'm setting it separately. And for AX2, I'm setting what type of plot it is. I'm just setting a plot. So what's the difference here? This plot function will be returning me a line chart, whereas this bar plot will be returning me in a histogram format. I'm setting the title, Y label, X label, and legend. And finally, I'm using a function called tight layout. Now, what this tight layout does is like it makes the appearance of the chart pretty much easier. It will not, it will remove if there's any congested things are there, it will put in a reasonable spacing. So kind of an, it adds more glamorous to the charts. That's what it does, right? So that's what a tight underscore layout does. It basically doesn't do any calculation at all, but it makes the appearance better. That's what it does. It's kind of an ease of use for the people who are looking into the charts. And plt.show, basically I'm going to finally show the charts over here. If I execute, I'll be getting a very good, decent output from the charts is what I'm going to get here. I'm getting the closing price. I'm also getting the volume data also. Right, so that is with the Matplotlib, but we also have more to that. So Matplotlib is not only about plotting the lines and histogram bars and frequency distribution. So we can also do a lot more on that. I'm going to show you about colors, Matplotlib supported colors. Matplotlib, right, it supports various different types of colors over here. So if I import the Matplotlib, so one thing you always have to check here is if you want to know what version of Matplotlib I'm using. So just import the package. I'm not adding any pyplot over here. I'm just simply saying Matplotlib. You just type Matplotlib. You put a dot over here and then put underscore, double underscore, version. And then again, double underscore. Now this will help me what package version it is. So 3.7.1 is the package version of the Matplotlib. So we can access not only the functions, we can also access the attributes or the variables inside the Matplotlib. So one among them is the colors. So matplotlib.colors.css4 underscore colors. This will give me a brief idea about very complete list of colors. You can see that Alice Blue is a color name. Of course, Alice Blue is also in the name of the broker also, but it is one variant of a color, right? It's a different shade of blue color, Alice Blue. Equivalent hexadecimal value is what I'm getting over here. Now you might wonder what are this hexadecimal value. Now this hexadecimal value, right? So this is like F0, F0, F8, and FF. So this is in hexadecimal format. And this represents a red color, and this represents a green color. This represents the blue color. So mix of red, mix of green, and mix of blue in various proportion, I'll be getting the Alice blue color. Maybe something like if I want to have a black color, I'm saying like 0 red, 0 green, 0 black. That means, I mean, 0 blue. If I mix all these colors, I mean, I'm not adding any shades of red. So 0% red, 0, not in percentage though, but I'll be having a scale from 0 to 255. That means in hexadecimal format, 0 to FF. FF means complete red color. 0 means no red if I'm putting in over here. So here I'm saying like no red, no shades of red, no shades of green, no shades of blue. That means I'll be end up getting a hexadecimal value. So hexadecimal value will be mentioned with the hash symbol. If I'm mentioning anywhere with the hash symbol, I'm giving those hexadecimal values. You will be able to end up getting the mix of those colors. Maybe something like white will be having like this. White RGB value will be having like this. If I mix full red, full green, full blue, this combination will be yielding me a white color. Probably you would have studied in your high school mathematics. I mean, not in mathematics, but probably when you try to mix the red color, green color, blue color with your pastel colors, you could have got the white color shades. Right. So when you work with pastel colors or crayons, when you try to have a mix of shades, you'll be having this white color. Probably you in your childhood, you would have tried those things. So that's what it is given in a RGB format. So maybe more on this, if you want to explore, you can just type hexadecimal colors. So probably you just go to your browser and then type hexadecimal colors. Right, so you'll be able to get that decimal color codes. Probably you can go and say like this RGB format. This is RGB format, red, green, blue format, and this is the hexadecimal format over here. I'm just selecting a shade of red or shade of green. So I'll be able to get that corresponding hexadecimal values, right? So corresponding RGB values also I'm getting over here. So that way you can go and play around. Now that is not the main theme over here. Maybe if I want to set those colors in my Matplotlib. So let's say I'm having an array values having 1, 2, 3, 4, 5, 6. And then I want to plot the array here. I'm just plotting. I'll say color lime. If I say color lime, it will be getting plotted in color line, right? Or I can also say like this. I can also use this. Let's say I want to put it in an alias blue color. Just copy this. So instead of giving that color here, right? Instead of plotting those colors, I can say like, I can put it in with a hash symbol, put those values. So now I'll be able to get the plot in an alias blue color. Somehow the plot is there, but it's very light. Maybe I'll try to have a different plot, maybe something like which is pretty much visible. Maybe I'll try to use this chart reuse, something like that. I hope this may not be a very mild color, like Alice Blue. Alice Blue is a very mild color. If it is thicker, you can see the lines which is getting plotted over here, right? So of course, you can use the color like instead you can give the chart you reuse also. So that is also you can use. You can either use a given hexadecimal value. You can give the color name if you truly know that. Or you're going to use the basic red color, green color or something like that. Just simply type red. So that also works. Or you can also use an standard colors. You can use like B or G. So let's say I want to plot in cyan color. I just simply type C. That will try to plot in cyan color. So C will try to plot me in a cyan color over here. C, if I say simply R, that means red, right? So that is red over here. So you can use different varieties of color format. That color format is a standard which is used in Matplotlib. And not only that, I can also look at that. This is something very interesting over here. Let's say if I want to do something like, maybe I'll try to pull up a very interesting example. Let's say, I'm sorry. So recently I was looking into one interesting example. I thought of showing you that. In, let's say FII, sorry, FII, or maybe I can say like a share pattern distribution. HDFC Bank. So if you want to see the shareholding pattern, you can maybe you can go back and look into the shareholding pattern, right? So how many percentage of HDFC Bank is held by FIs, and public, how much percentage they are holding, others, how much percentage they are holding, promoters, how much percentage they are holding, mutual funds, how much percentage they are holding. So if in case if you want to do this sort of visualization, now this is nothing but a basic pie chart. If you want to do that, you can do it in Matplotlib itself very easily using a pie function. So what I'm going to do here is I'm just having I'm just importing my Matplotlib as PLT. I'm setting the figure size, plt.figure. I'll be able to set the figure size equal to 12,26 is what I'm setting over here. So this will create a figure with 10 inches and 6 inches tall, right? So the height and width is what I'm saying over here. Width is 12 and height is 6 inch. And I'm giving a label. So I'm just giving a label like foreign portfolio investors, mutual funds, retail investors, insurance companies, and others. I'm also creating a list of sizes. So foreign FPI is holding 52%. Mutual fund is having 19.5, and size is like 11.2 for the insurance companies. I mean, insurance companies holding 9.1 and others are like 7.9. I'm also specifying the colors also. You can see that I'm using a mix of blue, orange, green for the blue for portfolio investors. I mean, FIIs, and mutual funds, I'm giving green color. I mean, sorry, orange color. And retail traders, I'm giving green color. And insurance, I'm giving some hexadecimal colors. And again, others, I'm giving another hexadecimal color. This also I'm putting in a list over here. Then I'm creating an explode tuples is what I'm creating over here. I'm creating a tuple 0.2, 0.1, and 0.0.0 is what I'm plotting over. I'll tell you what that explode means. It's a very interesting one. Then I'm plotting the pie chart. I'm setting the size over here. The size of the plot is what I'm setting. I'm setting the explode value. I'm setting the labels. I'm setting the colors. I'm setting auto percentage. I'm saying like you adjust only to one decimal only. That's what I'm saying over here. I'm saying like I don't want any shadows. I'm saying like start angle, you make the angle, twist the circle to 140 degree. So that means first value is for foreign portfolio investors, right? That will be shifted to 140 degree. That will change, that will rotate the circle 140 degree. That's what it makes. So that the chart will be a little bit looking something like this. If I execute that, you can see that the FPI is looking tilted over here. By default, if I don't give that, it will be using a zero value. The chart will be looking something like this. You can see that this is how it is looking like that, a semicircle. But if I rotate 140 degree, the entire data will be rotated 140 degree, so that chart looks pretty interesting. So you can twist and turn the way you want to present the data, right? And moreover, you can see that I'm using an explode over here. The explode is nothing but the gap. You can see that there is a gap between, I'm just giving a gap between the FPIs and mutual funds. Only I'm just giving a gap between the FPIs. I'm giving a 0.2 as a gap. So 0.2 shows how much gap it is. It's a bigger gap. And 0.1, I'm giving the gap for the mutual funds. So mutual fund is my second data. For the second data, I'm just giving gap. So rest all the things, right? I'm not giving any gap at all. So retail traders, insurance companies, others are very small data points. So I'm not giving any gaps at all. So that is how it looks like. So what we are setting over here, a big gap is what you're finding over here. That big gap is 0.2. And there's a small gap over here that is 0.1. And here we don't have any gaps at all. So that's why you're finding the value 0, 0, and 0 for those values over here. Right? So that is what an explode is all about. It gives an explosion impression that how the pie chart looks like. So that looks pretty cool here. So that way you can bring some intelligent way of presenting the data, right? And I'm also having a legend. You can see that where I'm adding the legend, I'm adding the legend location at the lower right. I'm sorry. All right. So that way I'll be able to add the legend at the lower right over here. All right, let's move a little forward. When it comes to Seaborn, they also support something called as a color palette. In Seaborn, right, they have a color palette. So you can use various varieties of color palette. When I am trying to plot, right, so by default, it uses the color palette. This is the color palette will be used. So whenever I'm trying to plot anything, it always plot in color blue. Maybe if I try to plot some multiple colors, it will be you choosing from the default palettes only. So automatically, it will be assigning those values. Now that is what an Seaborn color palette is all about. So maybe uh, we'll explore more on that. But before to that, which package I should use? Should I have to use Matplotlib? Should I have to use Seaborn, or should I have to use Plotly? See, Matplotlib is mostly, it's a powerful library undoubtedly, right? But it has a highly customized plots. Particularly many libraries like Seaborn, it uses Matplotlib in the backend, right? So Matplotlib is a very basic package. It's a static package, but Seaborn primarily used again by the data scientist, particularly for statistical visualization. A lot more complex statistical visualization is possible. Maybe if you want to know the capabilities of Matplotlib, what you can do is like you can directly go to the Matplotlib website and you can go through some of the examples. Matplotlib, just type and then go to the Matplotlib website. So you'll get to see what are the examples which are supported by the Matplotlib. So these are some of the type of plot which is supported by Matplotlib, right? So mostly, as I said, it is used in data science. Likewise, the Seaborn also, they have various capabilities. In fact, Seaborn capabilities are very much more better than uh, Matplotlib. So if you are looking for more jazzy one, you have to go for Seaborn compared to Matplotlib. Matplotlib is a very standard package. It doesn't look very jazzy. It gives a basic plot. But if you want to go for a jazzy plot, you have to go for Seaborn. And Plotly is even more jazzy compared to Seaborn. And it is even more interactive also. Seaborn is not interactive. Seaborn plots that in a very jazzy way, but it is not interactive plot. But Plotly is even more interactive. Many websites, they use Plotly for showing the information. So here also you can go back in the gallery and you can see different styles of plots, which is possible using Seaborn, right? So it supports various types. Now, when it comes to Plotly, the interesting thing is like it is even more interesting. Maybe when we explore Plotly, I show you how interesting it is, right? So let's go back to the code. So with this, Matplotlib is done. We'll get into something like Mplfinance. So Mplfinance is like I want to show you here. So I'm just trying to download the HDFC Bank data. Up to date is what I'm going to download here. 24, 1 and 20. Up to date data is what I'm trying to download here. So I'm going to show you the candlestick charts, bar charts, Renko charts, and point and figure charts. So plotting is very easier. So automatically, if you are having open, high, low, close, Mplfinance recognize it very easily, right? So if you are having the exact columns, open with the O capital and H with the H capital, L with the L capital, and C with the C capital. If you're having in that data frame, automatically it recognizes the open, high, low, close, and it automatically builds the candlestick charts, right? So it builds the candlestick charts. Not only that, it also help you in plotting in an OHLC format. Thing is very simple. Only date. Pass the data frame, mention the type as OHLC, set the title, and set the styles. You're good to go. Then talking about Renko. So here, when it comes to Renko, right, I'm just having a Renko parameter in a dictionary format. I'm saying like, I'm just want to have an ATR based Renko. I'm setting the ATR length as 14. So this is what I'm passing as a dictionary. This input is what I'm storing under a parameter. And that parameter is what I'm sending to the Renko parameter. So I'm sending the data frame. I'm sending the type as Renko. I'm sending the Renko parameters in a dictionary format. I'm setting the title and setting the style. So how do I know it's a dictionary or not? You just go to the plot and then you just type. So then you'll get to know more about how you should pass the values. So this way you'll be getting a Renko chart. So likewise, you're also able to get a point and figure chart also. Even this point and figure chart also, we are setting the ATR parameter. I'm setting the ATR length. So ATR based point and figure it is. So when I'm using the mpf.plot, I'm setting the type as PNF. PNF means point and figure. I'll be able to get the point and figure charts. Of course, it is not looking ideal. Maybe what should I have to do here? It's supposed to plot in a better manner. Or maybe the data what I'm using is a very limited amount of data is what I'm using here. If I increase the data length or something like up to 2020, maybe the chart might be getting even more interesting. If I'm downloading more bigger data length, maybe the point and figure also looking pretty interesting, right? So that is what it means over here. It automatically plots along with the grid as well. So it automatically plots the grid, it automatically plots the PNF charts. So that is what with Mplfinance is all about. It's a very interesting stuff though, right? Now, I'm sorry. So that is with Mplfinance. Mplfinance is basically used to chart the different style of candlestick charts. It also supports indicator also. I'm not denying that. But Mplfinance is not popular for indicators. For indicators computation, we use Pandas DA, which we will be discussing in our tomorrow chapter. Very elaborately, we're going to discuss about that. Now, let's move on to the next interesting one, the Seaborn tutorial. So Seaborn tutorial is very interesting. I'm actually trying to bring different types of functions is what we're going to explore in this tutorial over here. You see here, I'm importing the Yfinance, Yahoo Finance, I'm importing Pandas, I'm importing Seaborn as SNS. Whenever you are importing Seaborn, right, you also have to import Matplotlib also. You know the reason why? Because Seaborn itself a extended package which is built on top of the Matplotlib. So if you import Seaborn, you also have to import Matplotlib also, right? And here what I'm trying to do, I'm putting the tickers in a list. So I'm having some 4 tickers is what I'm having. HDFC Bank, Axis Bank, ICICI Bank, and NSE Bank. You see this exclamatory mark over here? That is nothing but it's an index. So I'm trying to download the index from Yahoo. And I'm not trying to download, I'm using the usual thing only. Instead of passing a single ticker, I'm passing the entire list itself, I'm passing over here. And I'm saying like, I don't want all the data frame. I just want only the adjusted close. Adjusted close of HDFC Bank, adjusted close of Axis Bank, adjusted close of ICICI Bank, adjusted close of NSE Bank. I mean, it's nothing but Bank Nifty. So I download and then I'm going to show you the data, which is how the data frame looks like. You'll be getting only the closing data of all those stocks. So Axis Bank data, HDFC Bank data, ICICI Bank data, and NSE Bank data. Nifty Bank, Bank Nifty data is what I'm having over here in a data frame. Now, why I'm doing this is like I want to show you how to build a relative strength charts. The relative strength charts which you get from TradingView, something like that. That is what I'm going to plot here. So I'm just getting the very recent data. So I'm just, you see the plot here, I'm just trying to download from 2023 onwards. I am trying to get till today, I'm trying to download here. That is a data frame which I'm getting over here. And once I got the value, I'll go and get the ILOC of 0. So ILOC of 0 will try to fetch what? Anybody? Can anybody answer here what data I will get? So I'll show you the data frame. You can just quickly type it out. Which row it will print? Will it print the last row or it will print the first row? First row, right? The very beginning of the data is what it will print. This is -1. If I want to print that, this is my ILOC of -1 is what I have to access. So I'm just getting the very topmost row is what I'm getting over here. So 940, am I getting over here? Yes, I am. 1610, am I getting over here? Yes, I'm getting over here. Likewise, 895 and 43,203 is what I'm getting the data. I'm also getting the index value also I'm getting over here. Separately, I'm getting over here, the index value. And the data type as well. What kind of data it is? It's a float 64 type data. Now, what I am doing here is, I am normalizing the data so that it always starts from the 0% for each stock and index. So I'm doing the entire data frame. I am dividing with the starting point of the data. Obviously, I'll be getting 1 because I'm dividing the same value with the same value. So I'm getting a 1. So I'm subtracting with subtracting with 1 over here. I'm multiplying by 100 so that I'll be getting a percentage value. How much percentage right now the value is deviated from the starting point. That is what I'm going to get it. So my data frame looks something like this. You see that all the value starts at 0, 0, 0, 0, 0. So now if I'm getting an 18%, that means Axis Bank had raised 18% since 1st of 2023, Jan 2023, right? Second Jan 2023, that is the first date of 2023. From there onwards, 18% it went up. Whereas HFC Bank almost went down by -8%. ICC Bank has been trading 11% since the last 1 year. And NSE Bank Nifty itself up by 5.7%. That is what the information I'm getting over here. Now I'm going to set the color palette. See, this is a default color palette, right? So the default color palette looks something like this. I say like, I don't want to use this default color palette. I want to use a different color palette over here. I'm saying like, I want a terrain as a color palette. Right? So this is how the terrain color palette looks like. So means if I'm trying to plot, it will be opting from these color set only automatically. I don't need to mention which color it is. It automatically picks up from the color palette. And what I am saying is like a plt.figure, I'm setting the size of the figure 15,8. 15 is the width and 8 inch is the height. I am trying to get the, first of all, I do one thing. I'm going to select this line and then I'm going to put an control slash. If I put an control forward slash over here, it will add an automatic comment over here. So it's a multi-line commenting technique. If I again put an control slash, it will be removing the multi-line comment. That's a shortcut key. So I'm just using the simple shortcut key to disable these lines. Maybe later on I'm going to use it. I'll show you that. As of now, I'm just plotting the line plot. I'm passing the normalized data frame, which we computed in the past. So we computed the normalized data, right? So this is the normalized data frame starting from 0. We are starting all the values from 0. And I'm showing the relative strength. So that is what I computed in a table. Now I'm going to do what? I'm just plotting those normalized data. I'm setting the title, setting the Y label, setting the X label, and setting X tick rotation equal to 45. I'll tell you what exactly it is. It is also a very interesting one. Not a mandatory one, but it will make your chart a little bit elegant. That's what it does. And I'm also using a tight layout that will make your chart looks readable. That's what it does. It will make your chart looks less congested. When you're having a lot more things, legend will be running on and title will be there and you'll be having that X ticks value. So, and a lot more things will be there in the chart. So it will make things looking elegant, neatly spaced. That's what the tight layout will do that. And finally, I'm showing you the chart. So this is how the chart looks like. So this is how my relative strength of the HDFC Bank, Axis Bank, ICICI Bank. So maybe if you're an investor, definitely you want to do some relative study right from the start of 23rd January onwards, which is outperforming, which is underperforming. Now you can clearly say that Axis Bank is outperforming, right? So who is underperforming? From the legend, I can see from the legend. You see the legend? It's a dotted yellow, green color line, right? So the dotted green color line is HDFC Bank. Obviously, HDFC Bank is underperforming. Axis Bank is outperforming. So these kind of simple study will be able to make it from here, right? So obviously, if I don't set the terrain, so here also I'm setting the terrain over here. See that the palette equal to terrain. That is what I'm setting over here. So this case, this will not set the terrain. This will show you what are the colors are there in the palette. That's what it does. If I don't set the terrain, if I don't set the palette itself, let's see what happens. If I don't set the palette, automatically it fetches from the default palette. We don't set the palette over here, it automatically picks up from the default palette. You can see that. So what is the default palette? So my default palette is this. So this is my default palette, right? So this is my default palette. It will be automatically picking the multi-line colors from these palettes. So that's why palettes are interesting, right? So there are a lot more things to do with the palettes. Maybe if you want to have more details about the palette, what you can do is like you can go back and read the documentation. You just open your browser and then say like Seaborn color palettes. And then you just go to the documentation and you read more about the palettes, different types of palettes, right? So what does it mean? How to set the palettes, how to get the, so this is again like they're having like tab 10 palettes. They're having a pastel palettes, muted palettes, bright palettes, color blind palettes, dark palettes. So they have a different styles of palettes over here. So you can just go and explore here and you can go and play with that. So whichever the palette that which you find interesting, you can go and get those information from the documentation. Documentation of Seaborn, Matplotlib are very brief library. Of course, it cannot be explained in a very short duration, like a 2-hour session. It cannot be explained. But as I said, I'm trying to do my maximum here, right? Followed by that, what I'm also going to show you here is like, I'm just trying to plot a random value. I'm just using a NumPy here. You know why NumPy is popular for? NumPy is popular for matrices. I'm just trying to create a 3 into 3 matrix, right? With random values is what I'm going to print. And what are the random values I'm trying to print? I'm going to use a heat map to visualize those things, right? I'm using a C map called Viridis. So this is also some sort of a color palette, which I'm using in SNS. So later on, I'll talk about the C map also. So you need to know a fair idea about what is a palette, what is a C map when you are dealing with C map, when you're dealing with SNS, Seaborn. So here, what it does is like, it brings me the matrix. So what are the matrix what I created? First of all, I'll show you the matrix here. So this is how the matrix looks like. So this matrix is what on top of this, I'm going to do a visualization. So let's say I'll add a code markdown and then I'm just, what are the matrix I'm having in data, which is nothing but a random matrix, 3 into 3 matrix. The 3 into 3 matrix is what I'm trying to visualize in a heat map. So I'll execute this. You can see that the exact same value I'm just getting in the, instead of matrix form, I'm just seeing in an color-coded heat map is what I'm using here. For that, I'm using a heat map function, sns.heatmap. I'll be able to get that heat map. I'm setting the size of the figure, and then I'm finally showing those values. That is what I'm doing over here, right? So that's a simple heat map using Seaborn, but I can also change the CMap value if I know the value, something like, let's say, red, maybe blue, and green. So GN is for green. Maybe if I know that, I'll be able to set a different style of, I'm sorry, maybe it's BU, I think, for blue. Or I can use yellow instead of YL. I'm sure about the palette. I think I can use, yeah. So this is like red, yellow, green palette it is. So it is using a CMap style. So varieties of CMap style, like how we have palettes. CMap also, we have various combinations of palettes, particularly for if you are a heat map user. If you want to plot heat map, then you have to know the CMap colors. So again, how to get the CMap? There is a function for that. It's a function from the Matplotlib itself. In Matplotlib, I'm exporting the pyplot. I'm just saying pyplot.color maps. So this will be getting me all kinds of colors. Right, you can see that this is like blue and green, BU and GN. So if I use BU and GN in my CMap, BU and GN, I'll be getting a shades of blue and green. That's what I get over here. So different CMap styles are available over here. So it's a very lengthier one, though. You can go and check it out, which one suits for you. You can use actually as it is. And we also have a reverse mode also. So let's say the previous one, whichever the color that I'm using, this is using a blue and green. If I use an underscore R to that, it reverses the color palette. So instead of wherever blue is supposed to get printed, it prints green. Wherever a green is supposed to get printed, it uses color blue. So that's how it is a reverse palette it is. So you can also use a reverse palette also, right? So just go back and experiment with the palettes and reverse palettes. It's pretty interesting though. So for time being, I'll maintain it like red, yellow, green itself, right? And if in case if you want to get the complete details about the palette, so here it is plt.color map that will get you all the palette colors. I mean, all the CMap colors is what you'll be getting over here. And particularly Viridis, Plasma, Inferno, and Magma are great for representing a range of data. But if you want to have a data center around a midpoint, you want to show that, you can use Cool, Warm, and Seismic. So here's an interesting example. This is a pretty bigger example though. Let's say this is one thing which I posted in my blog also. This will get me the returns, monthly return data is what I'll be getting over here. So something like this sort of plot is what I'm getting over here. So actually what is happening in the background, I'll tell you. So a lot of interesting things are happening over here. Particularly if you want to understand this, you'll be learning a lot of Pandas functions also. So basically, you can see that I'm having in Jan columns, Jan, Feb, March, April, May, June, July, August, September, October, November, December. And I'm also having an extra column called yearly column, which is the sum of all the uh, monthly returns for that particular year, right? So how this is formulated is what it is very interesting. So let's see one by one. I'm just importing all the libraries one by one, setting the ticker, setting the start date, setting the end date, right? I'm just setting the end date till 2nd of February. That's fine. So we don't have data up to 2nd of February. So how much ever the data till up to date point I'm having, that data will get downloaded. So I'm downloading the data and I am converting the data into monthly format. I'm resampling the data over here. So that entire data frame will be converted into a monthly data frame. Right? Now, from the monthly data frame only, I'm calculating the monthly returns. So I'm just having a monthly returns. You see that I'm not saving it to any data frame. I'm just putting only into the variable only, right? Now, what I am doing here is the monthly returns, I'm converting into a data frame. I'm converting into a data frame. So this is where the monthly returns are getting into a data frame. So let's take up to this point. Okay. So I'm just going to cut this. I'm going to take it up to this point. So finally, we'll be having what? Monthly returns underscore DF. So what I am having here in the monthly underscore DF, I'm getting a data frame like this. I'm getting an index. Index is not getting spoiled. It's getting along with that. Along with that, I'm also getting the monthly returns. Each and every month, I'm getting the returns. Of course, when I'm calculating returns, right, it will be, I should have used multiplied by 100 over here. Without multiplying by 100 only, I'm getting the values over here, right? Anyways, I have to multiply by 100 so that I'll get a fair value. Now, on top of this data, on top of the computed value, I'm just building a matrix over here. So how I'm building the matrix is matrix of monthly returns. Every year, I'm building a matrix over here. Every month in a year, I'm building a matrix over here. So I'm using a technique called pivot table as a function I'm using over here. I'm getting the values of the adjusted close from the monthly returns underscore data frame, right? So that is what I'm trying to do here, right? Monthly returns underscore data frame. I'm just sending the adjusted closing value. I'm passing like a monthly returns underscore df dot index dot year. So which year it is, I'm passing the data. And I'm also building a column also. I'm just setting the column like each and every month, I'm giving a name to that. January, February, likewise up to till December, I'm giving the values over here. Now, if I look into the matrix column will be looking something like this. Maybe I'll show you that. How the matrix column look like, I'll show you. Monthly underscore returns underscore matrix is what I'm going to show you, that how the data frame looks like. So this is a matrix data frame. So index, I am showing like only the year I'm showing over here. And the January month returns I'm showing, but still not multiplied by 100 yet. Likewise, February month returns. Each and every month return I'm just showing. If it's not having any data, for example, February 2024, I'm not having any data. So it is displaying non-values. Non-value means null value. Right. So on top of this, what I am trying to do is like I have to add an extra data frame. Extra series year is what I'm going to add here. That will have the total sum of all the month in a year. So that is what next I'm going to do here. So here I'm using a very interesting function. I'm using something called group by is what I'm using over here. Group by. So what group by does? Group by will group the particular year. So what are the year value I'm having of that adjusted close? I'm going to submit everything. That means sum of all these returns, right? From starting from every year, January to December, I'm going to sum up all the values and I'm going to plot as a separate column over here. That's what I'm going to do here, right? So that is what I'm going to trying to do in this example. So I'm just finally adding my matrix data frame is going to look like this. I'm having an yearly column now. You see that I'm adding to the yearly column itself. So what are the values that is calculated? I'm adding it directly to the new matrix column called the yearly. So the yearly column, I'm having it, which is nothing but what? This 0.17 is nothing but what? Sum of all the returns over here. That is what we are using group by function to calculate it. I'm doing a sum operation on top of all these values. So group by is a very interesting function, particularly if you want to add a sum of sum of all the values in a particular row or a particular column. If you want to sum up like that, then group by will be very, very helpful. Basically, you want to implement some aggregate functions, like sum functions, something like that. If you want to do such that kind of aggregate function, you can do it using the group by. And so we had this final table. This is what we're going to show in a heat map. So ultimately, we are using the Seaborn to display that. So I'm setting the Seaborn font scale to 1.2, setting the figure size as 14,12, sending the heat map. I'm setting the C map as red, yellow, green. That's the C map value I'm going to use over here. And the heat map itself, I'm passing the entire data frame. What are the data frame that we had prepared? I'm just putting the data frame font center equal to 0 and format 0.2%. That means it will be the value will be adjusted to 2 decimals. Here you can see that the values are not adjusted to 2 decimals. In the format section, I'm saying like you just adjust to 2 decimals. And then I'm also displaying the C bar. I'll also tell you what a C bar is all about. C bar is an additional information that I'll be getting along with that. I'll show you that. And I'm setting the X label, Y label, and finally showing those values over here. So if I execute this code, I'll be getting the final heat map. So I told you a C bar, right? So C bar, right now I'm not seeing any C bar here because I disabled the C bar. If I enable it true, that's an additional graph I'll be getting along with that, like a kind of a scale which shows how bigger the percentage it is. Right? That is what I'll be able to see over here. See, now you might be wondering how the values are getting multiplied. So here, if you could see, the value is like 0.17. 0.17 is the value I'm getting. But when I'm seeing in the heat map, I'm getting 17% over here. How this is possible? How this is possible is because of the formatting. I'm saying like 0.2. I'm not only saying 0.2, I'm saying percentage over here. So when I'm saying 0.2% in the formatting, it is automatically multiplying with the 100 over here. Right? So that is how the results are getting displayed in a percentage format, and percentage also coming over here. It is also the actual value is getting multiplied by 100. If I don't give the format, what happens? If I don't give the format, what happens? Whatever the value is there, it just gets displayed over here like a very congested format, 0.18, or it is rounding out to 0.18. But actually, that is not the one we want. We want in percentage format, right? So that's why we are putting the format as 0.2%, and then now whatever the value which is getting displayed over here, it is displaying like 17.85%. And I'm also having the kind of a C bar. This is what it's a C bar is all about. It says like anything above 0, it will be in green color shade. Anything below shade 0, it will be slowly transforming to dark thicker levels. So that is what the scale shows. If in case if you need, you can keep it. If in case if you don't need it to your for yourself, you can just disable it. So that control is already available there. Otherwise, C bar is an optional feature. Not everything is an mandatory one, right? So C map is also optional. If you don't set the C map, it will set the default C map. If I don't set the center, it always set the default center. Likewise, formatting, C bar, everything is optional over here, right? And when it comes to the month and year also, here also I'm able to set the font size. In the label also, I can set what kind of font size I want. And I'm finally showing those values. So that is with Seaborn. There are a lot more to that, but because of the time limitation, I'm just rushing up here. Right. So, but these are very interesting features about Seaborn. I think a lot more interesting information about Seaborn. You can go back and experiment on your own. But I think this session will be the basic learning about how you can use Seaborn, particularly from the stock market perspective. Now, the last one that we're going to discuss is about the Plotly, the most interesting and the most complex library and the most interactive library also. More than Plotly, more than Matplotlib, more than Seaborn, Plotly has varieties of features. Variety means you can't even imagine the kind of features it provides. So here I'm just importing Mplfinance. I'm importing Pandas TA, particularly for calculating technical indicators. I'm importing the Plotly submodule graph underscore objects is what I'm importing over here. And I'm also importing datetime object also. Right, so let me import here. So if I'm seeing a tick mark, that means it got imported. Then I'm going to download Tata Steel data. Up-to-date data is what I'm going to download here. I'm going to download the daily data is what I'm going to download. I'm also saying the interval. If you don't say the interval, by default, it will download the daily data. But if you are mentioning it, it's also fine. It also downloads the daily data only. So I'm just downloading the daily data in a data frame format. Now, on top of this, I'm calculating the simple moving average. I'm using ta.sma, right? So ta.sma does what? It does the simple moving average calculation. I'm passing the series, closed series I'm passing over here. I'm passing the length equal to 20. That means I'll be getting the 20 period SMA and 20 period, 50 period SMA is what I'm going to get. That also I'm storing inside a data frame. Same data frame is what I'm storing here as a separate two different columns. So if I see what is there inside the data frame, now I'll be having extra columns. SMA 20 and SMA 50 is what I'll be having as an extra column. Of course, it is having a non-values there. Now, what I'm going to do here is I'm going to plot the I'm going to plot the moving average also. Along with it, I'm going to plot the candlestick also. So for plotting the candlestick data, so I'm just saying like go.figure. So go is the what? So go is the alias name of the Plotly, the graph object. Geo means graph object, right? So that graph object dot, I'm just putting in figure over here, figure function. So this figure function is used to plot the charts. So inside that, I'm just passing the data frame. I'm saying like I'm passing, I want like go.candlestick charts. I'm sending the index, which is nothing but the date and time value. I'm sending the open, high, low, close value is what I'm sending inside to plot the candlestick charts. And then I'm adding an extra trace over here. So trace are like kind of an additional values that you want to display, right? Extra values in the same block of value. I also want to display the simple moving average in a line format, right? I'm also giving a name to that as well. So this will be shown in the legend. Automatically it draws the legend. You don't need to specify the legend here. Automatically it draws over here. So here add trace is to add extra in the same charts. It's kind of an overlay charts. That's what we call it as. Like something like an moving average, we'll be plotting on top of the candlestick. Bollinger Band will be plotting on top of the candlestick charts. So those are nothing but then additional traces. So I'm adding a two trace over here is what I'm adding. And before displaying, I'll be updating the layout. In the layout, I'm setting the title, I'm setting the width. So here the width is in terms of pixels, right? So if you remember in Matplotlib and Seaborn, we set in terms of inches. So here we are setting in terms of pixel. So 1000 into 800 pixel is what I'm setting the height and width. I'm setting the x-axis title, y-axis title. I'm setting over here, right? I'm also enabling something called range slider. I'm just disabling it. Otherwise, I'll be getting something called range slider. I'll show you that what exactly it is. I'm removing the range bar slider. I'm just removing that. And I'm also setting type equal to category. I'll also talk about that as well. So first let me execute this, then we'll study what are these things are all about. Let me execute this. So now we can see that I'm getting the Tata Steel charts with you can see that the legend automatically gets plotted. I'm not mentioning anywhere about the legend here. Or legend automatically comes over here. I'm getting the title value over here. I'm getting the price and probably I'm getting the date value also over here is what I'm getting over here. Now, what is so interesting here is why I should use these other things. If I don't use this, say if I don't use this, the Plotly will be plotting along with, if it is a time series data, it will plot along with a slider. You can see that it also comes with a slider here. So I can adjust the slider. I can say like, I want to see data only between these two values only. So likewise, you can adjust the slider over here. So that way you'll be able to see the slider and you'll be able to adjust the slider over here. If you don't want the slider, you have to disable using the command, right? So in your update layout, you say like x-axis range bar range slider underscore visible. You make it false so that the range slider will go away. So particularly some cases, right, you don't want a slider at all. In that case, you can just simply remove it just by giving the parameter. Just to give that false, automatically it goes away. Now, the other one is again a very interesting one. I'm just passing a dictionary over here, dictionary of parameter. If I don't pass this dictionary, I'll tell you what happens over here is like, it will come up with space between Saturday and Sunday. So one thing about Plotly is like it is also interactive charts. So means I can zoom it, pan and zoom. These kind of things are possible over here. And if I keep my cursor over here, it plots me, it shows me open, high, low, closing value. So these things are not possible in Matplotlib and SNS, I mean the Seaborn, right? So that is why Plotly is very interactive. You can hover over a mouse cursor over here and then you can get to see that. Now you can see that there is a big gap between the over here. There is a gap is there. So why the gap is there? Because maybe market holiday, or there could be a Saturday or Sunday. There could be a holiday over here. Because of that, some reason Plotly is having the gap, but I can simply remove the gap by saying the setting the category. So if I set the type as category, then all the bars will have the equal space. That will remove the holidays. That will remove the Saturday and Sundays. So that will make your chart looking interesting. I mean, that is how you have to plot. You have to always type the set the category in the type section, and you have to pass it as a dictionary, right? So that will make your chart looking a bit interesting. And the end tick over here, mostly it is used for alignment of the x-axis title over here. So maybe you can see like if you want to have an alignment, so you can say like 50, you'll be getting very less alignment over here. If I say like 20, maybe the end ticks. So again, Plotly decides that how to align everything. So we cannot get to choose because I'm saying tick mode as auto. Plotly, you can see that it is showing like in a slanting mode, it is trying to align over here, right? So that is one more thing. And the most interesting thing is like I'm adding another data frame. I'm adding RSI. I'm computing RSI over here. I'm adding as a separate column to the data frame. Let's say the data frame contains, now I also have the RSI value. Also one more extra column I'm adding over here. I'm using the Pandas TA to compute the RSI. I'm calculating by passing the closing value and length of the RSI is what I'm passing. And finally, I'm getting those values over here. Now, once I'm done with that, now what I want to do is like I want to plot like a subplot. So if I want to do a subplot, I have to import another module called plotly.subplots. And I want to import a particular function called makeplots is what I'm importing. Okay. See that I'm using from. So from the main module plotly, submodule is subplots. I'm importing the function makeplots. The makeplots is what I'm going to directly use over here. Right. So make plots, I'm saying like I want 2 rows and 1 column. So 2,1 is what I'm going to say. So main one row for plotting the candlestick charts, another row for plotting the RSI charts. And I'm giving vertical spacing between the candlestick charts and RSI. I'm just giving some small space is what I'm trying to give over here. So subtitles I'm plotting. One is Tata Steel candlestick charts, another one is the RSI. I'm also setting the row width also, how the row width should look like. Then I'm plotting the first trace. I'm adding the candlestick charts. In the same one, I'm also adding the SMA 20, SMA 50 I'm adding. And additional trace, I'm adding an RSI value over here. So which row you want to add, you have to specify the row and column also. So here we mentioned 2,1, right? So 2 rows and 1 column is what we are having. Means the structure of the charts will be looking like this. So here I'll be having a first row where I'll be displaying the candlestick charts along with the EMA values is what get displayed. So I'll be having 2 EMA values. And the second block, I'll be having the RSI value. So RSI value is what I'll be having over here. So first row is 1,1. So first row, first column. This is like a 2,1. Second row, first column it is. So only RSI is getting plotted. See that RSI I'm plotting in row 2 and column 1. Rest everything in 1,1. 1,1 here, 1,1 here. That's what is getting plotted over here. So this is candlestick charts. This is candle. And this is nothing but the SMA 20 and SMA 50. I'm plotting everything in row 1, column 1. Right? So that is how I'm differentiating the subplot. Most important thing here is you have to import the make subplot function from the subplot module inside the plotly. So that is what you have to import. I'm also giving a vertical spacing also 0.03. I'm just giving over here. Right. So once I'm done with that, I'm setting the x-axis, y-axis. I'm updating those values as RSI and date. And then I'm finally updating the values. I'm saying like what is the width of my chart, height of my chart, y-axis title, and I'm removing the range bar, range slider visibility. I'm just removing that. And I'm passing the dictionary and just passing the type as category over here so that equal spacing between the bars will be there, ensured, and holidays, if there is any gap between holidays, it will totally get removed out. Otherwise, if you just simply plot like that, you might get up some mixed values. Definitely the chart may not be looking good. So definitely you have to set the type as category. That's a very, very important thing when you're dealing with Plotly. Right, and I'm just showing legend equal to false. I'm just removing the legend. If you want legend, you can, by default, it shows the legend. If you don't want that, you have to mention it in the update layout function. So how your chart need to be displayed, you have to give the complete details about that. Right. So finally, I'll be getting the candlestick charts, plotting with an EMA values, SMA values, and the RSI value. I'll be getting over here. These values you can go back and compare with TradingView charts. Perfectly will be matching, right? And the most important thing is like Plotly is famous for various visualization technique, lot more visualization technique. But one among them is what I'm going to show you here. So I'm going to read a CSV file from my internet. So this is the internet file which I am having. I uploaded sometime back in GitHub. So I'll show you here. So this is the data I uploaded. So which contains the weightage of each and every individual stocks. All the Nifty 50 stocks weightage is what I'm having over here. Now this data, if I want to download from the internet, so which is there in the GitHub portal, I had uploaded some time back. So probably I think some 2 weeks some time back, I had uploaded this. I can use the read CSV function to read not only the internal files, but also any files from the internet also I'll be able to read that. So I'm just reading the data frame. I'm just displaying the data frame. So this is the data frame that I'm having over here. It get me the symbol, what is the percentage change, what is the index weight of that particular component. You can see that HDFC Bank is having the highest weightage, 13.67. Means even a small move in HDFC Bank, it can make a bigger price action in Nifty, right? So in Nifty or Bank Nifty, it can create. If HDFC Bank is having a big moves, then it can disturb the Nifty heavily. Nifty, HDFC, Reliance, ICICI, Infi, ITC. So these are heavyweight components. So if you want to see if you want to study the heavyweight components, or if you want to visualize the market cap of those companies, so what we can do is like we can do something called a tree plot. So in tree plot, we can do what I'm trying to do here is like in the market cap section, I'm just doing some data dusting over here. I'm just trying to replace if there's any space, any special symbol. Sometimes I might come with a comma. It might come with that. So I'm removing those extra values, right? So I'm just doing some data cleaning over here. And finally, I'm getting the actual data is what I'm getting. So you see that I'm getting the percentage value and all I'm getting over, which I want to get rid of that. Sometimes I might get comma separated values. So I'm just removing the commas. I'm removing special symbols if I'm having anything, white spaces if I'm having anything. I'm just simply replacing those values. So that is what I'm trying to do here. So once that market cap is getting data dusted, so maybe I'll show you how this entire data frame looks like. So now after doing the data dusting, the market cap in the section will be looking like this. You can see that market cap, right? It is having comma separated values. Probably you can see that the Reliance HDFC Bank is having a comma separated value that is getting removed over here. Right. So now we can see that it is the comma separated value with thousands separators has been removed. Any thousand separator or million separator or billion separator, if you want to remove it, then you can use the replace function. So we are using something called regex. I'm not going to go detail about the regex over here. You just Google about it, right? So basically, it's all about formatting the data with regex. Slightly a complex topic though. I'm not going to go detail into that. So what this line of code does, I'll tell you. It just removes the comma or any kind of special values. It just simply removes that. Now, once it is done, once that market cap data is cleaned, so that now it will be good to plot those values. So what I'm trying to do here is like I'm replacing the symbol column with a company column. I'm just creating an extra column with a company name. That is what I'm creating over here. I'm also having a label over here. I'm applying a label over here. So now after applying the label, the data frame looks something like this. So this is how the label looks like, because this label is what I'm going to display in my charts. So I'm going to show HDFC. Below to that, I'm giving a small break. It's a HTML function. And then I'm just displaying the value with a rupee symbol is what I'm displaying over here. And that is what the label is all about, right? So once I prepare this data, finally, I'm just going to show the label column only. This value is what I'm going to pass it inside the tree plot. So this value, I'm just putting in a tree map plot. I'm sending the label. I'm setting the values of the market cap. So based on the value of the market cap, the box will be decided. And the tree map plot looks something like this. It's a pretty interesting one. Simple data visualization can be done over here. So now we can see here which company is having a big market cap. So HDFC Bank is having a big market cap. After that, Reliance, followed by that ICICI Bank, Infi, ITC, L&T, TCS, and Axis Bank. Right. So if these companies move bigger, right, then it can heavily impacting the Nifty over here. So that is what we can visualize. Nothing much over here. Otherwise, there are small companies like something like UPL. Even if UPL is making 20% move on the upper side or downside, hardly Nifty will not get disturbed much. Right. That is because it's having a very low weightage in the counter. So if it is having a low weightage in the counter, it will not be impacting the Nifty heavily. Right, but even a small move in these counters, it will be impacting the Nifty very heavily over here. All right. I guess there are a lot more to that, but I would like to stop here. I'm sure you would have definitely learned more interesting concepts about data visualization, right? So you would have learned about how to build the basic candlestick charts with indicators. Maybe in tomorrow's session, we'll explore more about various Pandas TA functions and maybe various TLib functions and a lot more things we'll explore here. So you let me know if you have any questions so that I would like to answer the question here. Is there any question? So Jasper is asking, when counting from the top, we consider 0, 1, 2, 3. But when we counting from the bottom, why don't we consider 0, -1, -2, -3? I don't know. Basically, they start from -1 only. And that is the standard formatting of the data frame itself. That is how the Pandas data frame itself designed. Not only Pandas data frame, but that is how the Python itself got designed over there. So we can't complain on that. Why it is not starting from 0? Because 0 already points to the starting of the value. Right? So -1 means it always implies the recent record. So that is how Python works. And based upon Python, NumPy, everything, list, everything is designed based upon the very basic structure of the Python itself. I guess that explains Jaspar's question. So there is an anonymous attendee is having a question. I have a question related to today's topic. Like you showed in the strategy comparing today's close with previous close. What if I want to compare the highest open interest in the option chain for Reliance? See, of course, first of all, you have to prepare the data. From the data, you can use the Pandas operation and you can get the highest value in that. So that should not be a rocket science. So Manish is asking, my humble request, please show how to plot highest open interest on call side for the entire week of Reliance having SNS line plot, if not just a roadmap. See, maybe I'll try to explain this. Maybe tomorrow's session, when we are trying to plot, I'll also take an example from the call side and the put side, how to get that in an SNS plot, Seaborn plot, and how we can also show the highest open interest, which one is having the highest open interest, whether call option is having a highest open interest or put option is having a highest open interest. I'll show you that. Maybe it's going to take a little bit of time, but tomorrow I'll show you. Because if I want to do that, I have to sit and code and everything. So maybe I'll work it out today and tomorrow I'll show you the output, right? I'm already having the output of getting all the complete call option, put option in a list. All I have to do is I have to sort the value and then I have to display the value. That's what I have to show that. Sorting, after sorting the value, whichever is the highest value, I have to show that highest value, right? So that is what I have to do. Maybe in tomorrow's session, I'll show it in a practical way. I'll show that things. So Durga is saying how to save the chart, for example, in MS Office. See, saving the charts is not a big deal. So maybe you can just here, right? You can have a download. You can just, that's download option is there. You just download it to a new plot. Then you can include in your MS Office or Doc or wherever you want. You can use that, right? So basically, you'll be getting a plot like this. Will be getting saved as a PNG file. What you can also do here is you can also use something like if it is using a Seaborn or something like that. So let's say I'll go back to a simple Seaborn tutorial. Maybe let's say this one you want to show it as an image. If you want to save it as an image file, you can use plt.savefig and you can give an image name. So let's say I'm just giving an image name like my heat map. So if I try to execute this, this will probably, I'm sure, first of all, I have to convert this into image. Let's say I have to write this formula. Maybe otherwise it might get mixed up. I have to interrupt the kernel here. So I think you can use the save fig and then you can give the file name. It will be saving into the PNG file. So you can see that it is getting saved as a PNG file. It's, I don't know, it's taking too much of time though, but the image file is here. You can see that. So it automatically gets saved as a PNG file. I don't know why it's taking too much of time. Maybe let me try to interrupt the kernel here. But it doesn't matter. Later on, I'll try to do that. Okay, next question. So how to save these charts? I showed you if it is Plotly, you can right click and save it. Otherwise, if it is something as some other different charts, you can just use the save fig function and you can save it as a PNG file or something like you're having something like a heat map or something like that. Right. You can also do what? I mean, in my case, I might be sometimes I'll be using an Snagit kind of tool. I just take a snippet of that thing. Maybe if you're using Windows, you can use some snip tool you can use. That way also you can do that. Programmatically, if you want to download, you have to use the save fig function only. That is what you have to do. So maybe I'll try to, I'm just putting the value over here. I'm just plotting the function. This function will be saved the figure also. So this here I'm getting the image. So the image is saved over here as a separate inside the folder itself. It is getting saved over here. So save fig function will save it as a image format. This works only for what? It works only for Plotly and I mean not Plotly, Matplotlib and Seaborn, right? Whereas when it comes to Plotly, you can readily, there is a save button. Is just hover over your Plotly charts, take a thing, and then you store wherever you want. Let's say candlestick charts. Sorry, tree plot. So I just save it, and the data gets saved over here. So automatically, it's trying to import also. That's fine. So here it automatically gets saved as a tree plot. Maybe I have to save it as an image file. I think. So let me rename. I have to give .png, I think. Along with that, if I give the PNG, I'll be able to see the PNG file, right? So whenever you are saving, ensure that you are saving with the .png as an extension so that it gets saved. And later on, you can import in your studies. You just copy it and then import in your notepad or something like that. That's totally a possible one. All right, so I guess more or less we had came to the end of the today's session. So tomorrow's session, we're gonna discuss a lot more interesting stuff. Maybe I'll also try to show you some sample strategy, how to do the backtesting. And I'm also gonna show you how to use Pandas TA and the TA lib indicators, which one is the fastest one and how to plot various indicators. I mean, how to compute various indicators. So that is what we're going to do more in tomorrow's session. So we're going to learn about indicators and we are also going to do some operations on top of the indicators after calculating it. And then I'm going to show you some very basic backtesting process is what I'm going to show you. I'm going to use vector BT for that. So let's see in tomorrow's session. All right. See you tomorrow. Thank you.